Good evening, students. So today we will be discussing a very important topic of coordination compound, that is valence bond theory. Okay. So today we are going to discuss this valence bond theory, which is a very important point of the coordination compounds. Okay. Actually, what this theory is about, it explains us the bonding between metal and the ligand. Okay, that how ligand is attached to the metal. Okay, that type of bonding is explained by the valence bond theory. Explains bonding between metal ion and the ligand. Okay, now this we have already discussed in our previous classes, that number of ligands which bind to the metal atom, okay, that is called as its coordination number. Okay, we have already discussed that what is the coordination number. Coordination number is the number of ligands which are attached directly to the metal atom. Okay, that is the coordination number. Now proceeding that, we have to discuss that how that ligand, how do that coordination number ligands, they are attached to the metal ion. Okay, that is what we have to discuss today. So this in this bonding, there are complexes which are formed of two types in case of valence bond theory: inner orbital and outer orbital complexes. These two type of complexes are observed when we go according to the valence bond theory, that the bonding between the metal ion and ligand is happening. Okay, so in this, one more important thing, what exactly is happening. Firstly, we will be understanding the basic point, and then we will be going through the bookish language. Okay, because if you guys will be having that basic point, that what exactly they want to say, okay, only then it will be quite beneficial for us, and it will help us to stick to the concept properly. Okay, so the basic agenda of this theory is that this theory says that the ligands, okay, they use different orbitals of the metal. This is the metal. Okay, it says that for bonding to happen, the ligand, it uses different orbitals of the metal. Okay, now in the metal, ns, np, n-1d, nd, all these orbitals are present. Okay, so this theory says that the ligands, they are utilizing the orbitals of this metal in order to do the bonding properly. Okay, and on the basis of the types of orbitals used, that what type of orbital is used by the ligand of that metal, the complexes, they have been classified into two types: inner orbital complexes and outer orbital complexes. Okay, inner orbital complexes, they are also called as low spin complexes, and outer orbital, they are also called as high spin complexes. Okay, inner orbital and outer orbital. Now we will discuss that these two types of orbitals in detail differently. Okay, firstly we will discuss about inner orbital complexes. These inner orbital complexes, they are also called as low spin complexes. Okay, low spin complexes. As the word states, inner orbital, what do we get, what the point that we get from this is that the orbitals which are present in the inner side, they are being used. How? See this. In this, actually, how do we explain this inner orbital and outer orbital? That is on the basis of ligands. The type of ligand which will be there, that will be deciding which orbital to be used. As I earlier said, that ligands will be using the orbitals of the metals. Now, the type of ligand it will decide that which orbital has to be used. Either if that orbital has to be inner, or if that orbital has to be the outer orbital. Okay, so that will be decided by the ligand. Okay, it will decide that either if it has to use inner orbital, or it has to use the outer orbital of the metal for the bonding. Okay, now in the inner orbital complexes we will be discussing. In this, we will take an example. Okay, I will take the example of CONH3 3 positive. Okay, now ammonia is such a ligand which prefers the inner orbital. Okay, and that is why it forms inner orbital complexes, this ammonia ligand. Okay, see this. Cobalt over here is an 3 positive oxidation state, right? It is an 3 plus oxidation state. I will tell you that how the 3 positive oxidation state we have discussed. See, earlier cobalt, it is having how many electrons? That is 27 electrons it is having. Okay. Now in the 27 or electrons, argon 4s2 and 3d7 is electronic configuration. In CO3 positive, when 3 electrons are lost, 2 will be lost from 4s and 1 from the 3d. So its configuration will become argon 4s0 and 3d6. Okay. To this, we can write it as like this is 4s. I will be writing 3d earlier, and this is the 4s. Okay, this is 3d. Now in 3d there are 6 electrons. How those 6 electrons are present? Like this, right? Now what will happen, this NH3 ammonia ligand, because it is a low spin complex. Okay, because it is a low spin complex, so it will be using the inner orbitals. Inner orbitals means that here 4p orbitals are also there, and here the 4d orbitals are also there. So which d orbitals it will be using? It will be using the d orbitals which are present in the inner side, means 3d, not 4d. 4d are outer ones. Okay, it will be using 3d orbital, which is the inner orbital. So how it will do that? In this, there will happen pairing of electrons. Okay, there will happen pairing of electrons. So these 3d electrons, they will get paired like this. This one will come here, this one here, and this one also in this orbital, because one orbital can accommodate 2 electrons. So in this way the pairing has happened. Okay, this is 4s and this is 4p and this is 4d. Okay, 3d, 4s, 4p and 4d. Now we are having the coordination number equal to 6, means that 6 ammonia molecules will come over here and they will be giving their electrons in the different orbitals of the metal and will do the bonding. Now one ammonia molecule will come over here, one here. Okay, one in the S, and 3 ammonia molecules will come in the 3p orbitals. So 2 d orbitals are used, that is d2, 1 s and 3 p. So it forms the hybridization d2sp3. Okay, so d2sp3 hybridization is formed. Why? Because these orbitals, which orbitals are used? Inner orbitals are used. By which ligand? Ammonia ligand. And that ligand will be deciding which orbitals to be used. So it has formed the hybridization that comes out to be, that is d2sp3. Now d2sp3 hybridization it corresponds to which geometry? That is octahedral, right? D2sp3, it corresponds to the octahedral geometry. So this is the exact case in case of inner d orbital. Okay, that is decided by the type of ligand, because this ligand is low spin. Okay, this ligand is weak field ligand. Okay, so this is the case of inner orbital complexes that we have discussed. Now we will move on to the high spin complexes. In high spin complexes, that is outer orbital. Okay, that is the outer orbital complexes. What is the meaning of outer orbital? Now it will not be using the inner d orbital. It will be using the outer d orbital, which is the 4d orbital. Okay. Now its example, if we discuss, that is COF6 3 negative. Okay. COF6 3 negative is the example of outer d orbitals. Why? Because this fluorine, it prefers to do bonding in the outer orbitals. Okay, so in this again, we will firstly find out the oxidation state of cobalt. Okay, that is x minus 6 equal to minus 3. So x is equal to plus 3. Cobalt is again in the plus 3 oxidation state. So as it is in the same plus 3 oxidation state, means that it is again having this 4s0 and 3d 6 electrons. Okay, so that is cobalt 3 positive means 4s0 and 3d 6 is the configuration. We will draw it like this. This is 3d, 4s, 4p, and this is the 4d, which is the outer d orbital. Okay, in 3d there are 6 electrons which are placed like this. Okay, now in the previous case where ammonia was there, there was happening pairing of electrons, right? Now if we are to form the high spin complexes in these outer orbital complexes, the pairing of electrons do not happen. Okay, pairing of electrons, they don't happen in 3d orbital. In case of 3d orbital, the pairing will not be happening. Okay, so then what will happen? This fluorine, it will first come in the it will donate its electrons in the 4s. Okay, 3 fluorine atoms will be accommodated in the 4p. Okay, and 2 fluorine atoms will be there in this 4d orbital. Okay, so 1 in the s, 1s orbital is utilized, so we will be writing at s. So 3p are used, sp3. 2d are used, so that is sp3d2. So in this case, the configuration, or the the hybridization, that comes out to be the sp3d2. Now d2, which is written after the sp3, it denotes that outer d orbitals have been utilized over here. And in this case, again, the geometry will be octahedral. Whenever we are having the coordination number 6, always then the geometry will be octahedral only. Okay, now there will be question in you in the mind of you guys that, sir, why pairing is happening in the low spin complexes and why pairing is not happening in the high spin complexes? Only what is the difference between them? What is deciding them to be outer orbital or inner orbital? That concept of pairing, right? Here the pairing of electrons was happening, which was deciding that in this case inner d orbitals will be utilized, And that's why we came to know that yes, the hybridization is D2sp3, right? How inner ones are formed? Because the pairing is happening, and that is why the ligands, they are being utilized in the d orbitals, inner d, right? And here the pairing is not happening, so automatically we have to shift to the outer d orbitals, right? So that concept of pairing was not explained by the valence bond theory, and that is the major drawback of this theory. Okay, but now the question is that why we are discussing, because this is a very important part of CBSE questions. Okay, every time this is a pet question of CBSE that they ask this a number of times in the board exams, not only CBSE, in every state board exams, this concept of outer orbital complexes and inner orbital complexes is repeated and asked a number of times. Okay, so this has to be decided. Okay, and as I already said, that the type of ligand will be deciding which type of complexes have to be formed. The outer orbital complexes, which are high spin, or low spin complexes, which are inner orbital. And that will be decided by the ligand. Okay. In inner d orbital, we have already discussed. In inner ones, the inner d orbital is being utilized. And in the outer orbital complexes, outer d orbital is being used. And what is the difference between them? How inner and outer is used? That is decided by the concept of pairing. If pairing is happening, then inner d orbitals will be utilized. And if pairing is not happening, then outer d orbitals will be utilized. Okay. Some more examples of the ligands which form low spin complexes, okay, that is CN, cyanide, okay, and high spin complexes are also formed by the chlorine, fluorine, cyanide, ammonia. These are the ligands which form these low spin and high spin complexes. Okay, so this is about the high spin and low spin complexes, which is the main point in the valence bond theory.